Today we are going to review two-step equations and try a couple of special cases. So here we have 3x plus 7 equals -5. So to start, I box my variable term and draw my balance line. Now, here we've boxed our variable term, like I said, and we want to get that alone. So to do that, we ask ourselves, how do I get it alone? And that means I need to subtract 7. So I subtract 7 on both sides, and I am left with 3x over here that can now come out of the box. And then -5 minus 7, -5 minus 7. We know that to subtract integers, we add the opposite. So -5 plus -7 leaves me with -12. From here, I go ahead and know that I need to get that variable by itself. So I ask myself how to do that. I am multiplying here because it's a coefficient and a variable next to each other. So to inverse that, I divide. I divide on both sides. I'm left with x over here, -12 divided by 3. 12 divided by 3 is 4. Negative divided by a positive is negative. So my solution is x equals -4. Now, we know that I go ahead and plug that back in. So I've got 3 times -4 plus 7, which gets me -5. Well, 3 times -4 is -12 plus 7. Does that equal -5? Yep, if I have 12 negatives and 7 positives, I am left with -5. Therefore, my solution of x equals -4 is correct. All right, so now we've got some special cases. Let's start with this one. Here, typically, for example, over here, we've got that multiplication, which is attached to that variable. So this is your variable term. If you think about it, like order of operations, if I were to just evaluate all of this, I would multiply first, right? And then I would add. Here, although we follow PEMDAS, technically this is grouped together, that x plus 7. So that itself is a term. So x plus 7 is what gets boxed. And we actually inverse that division first. So the inverse of dividing by 6 is multiplying by 6. We do that on both sides. I forgot my balance line. Times 6. Those cancel then. Now I'm left with x plus 7 by itself equals 18. And now I can just continue from there. So when I have a variable and a number, if I have two terms on top of that division bar, this is the term that gets saved, and we get rid of that division first. Okay, so now I want to get that x by itself, so I subtract my 7, leaving me with x equals 18 minus 7 is 11. I can plug that back in, and then that means I'm kind of doing the reverse here, x plus 7 over 6. I need to evaluate that first. 11 plus 7 is 18, divided by 6 is in fact 3. My solution of x equals 11 is correct. Let's try one more of those. We've got -3 equals -4 plus x, all divided by 5. So again, I've got that balance line. Now, once again, because that -4 plus x is together up at the top, those have to stay together to start. I can't separate them until I've gotten rid of that 5. To get rid of that 5, it's dividing by 5, so I multiply by 5. I do that on both sides. I'm left on that right side with negative 4 plus x equals 5 times 3 is 15. Positive times a negative is negative 15. And now I just have to get rid of that negative 4. So we know that negative 4, to inverse that, we have to add 4 on both sides. Even though there's an addition sign here, this is negative 4. So we do need to add positive 4. We've got x negative 15 plus 4 gets us negative 11. We go ahead and check our work. Negative 3 equals negative 4 plus negative 11. Oops. All over 5. Negative 4 plus negative 11 is negative 15 over 5. 15 divided by 5 is in fact 3. And because we've got a negative divided by a positive, it will be negative. And therefore, our solution of negative 11 times x is true. So once again, when you've got that two terms on top of another number being divided by another number, together we need to go ahead and evaluate that first.